Hi, welcome to part 1 of the video series about laws of motion. In this video, we are going to learn definition of force, types of force, and how to draw free body diagrams. There are a lot of different definitions of force. Here, we will use the one which is acceptable in a caps-align test. Force can be defined as any kind of push or pull on an object, which results from its interaction with another object. Force is a vector quantity, and the unit of the force is Newton. If you want to learn about vectors, click on the link at the top of the screen. A force can be classified as either a contact force or a non-contact force. Contact forces are forces between objects which are touching each other. Examples of contact forces are push and pull forces, tension force, which is defined as the force transmitted through a rope, string, or wire when pulled by forces acting from opposite sides. Friction force, which is the force that opposes the motion of an object and acts parallel to the surface the object is in contact with. We will learn more about friction force at the end of this video series. Normal force, which is the force exerted by the surface on an object in contact with it and acts perpendicular to the surface. Again, we will learn more about normal force in upcoming videos. While for contact forces, objects must touch each other, non-contact forces or field forces are forces which act over a distance. Objects do not have to be touching. The most common examples of field forces are gravitational force, magnetic force, electrostatic force, and nuclear forces. As we mentioned before, force is a vector quantity. In some questions, we will be asked to do some calculations with one or more forces. Sketching these forces may help us a lot for most of these questions. Free body diagrams are one of the methods to do so. In a free body diagram, we represent the object as a dot. The forces acting on it are arrows that point away from the center of the dot. Let's have a look on some examples. In the first example, an object on a smooth surface is pulled by a force F. In the free body diagram, we replace the box or the object by a dot. Now, we have to draw all the forces applied on this object. Let's start with the most obvious one, the pulling force F. We start drawing the force from the dot, and its direction is to the right. The next force we will draw is the force of gravity. It is the force applied on an object by Earth. All objects on the surface of a planet are pulled towards it, so the direction of this force will be downwards. The last force we are going to draw is the normal force. As we mentioned before, it is the force applied on an object by the surface, and it is always perpendicular to the surface. The direction of the normal force will be upwards, as it is applied by surface on the object. The sketch below is the free body diagram for the object in the figure above. In the second example, we have an object hanged from a ceiling. Again, we start free body diagram by drawing a dot instead of an object. We have two forces applied on this object. First one is the force of gravity. As usual, we draw it downwards. The object is hanged from a ceiling by a string or rope. As we mentioned before, the force on a string or rope is called tension force. Rope tries to lift the object and prevents it from falling down. So, the direction of tension force in this case is upwards. There is no normal force in this question, as object is not touching any surface. In the last example, we have an object resting on a rough and inclined surface. As a rule, we start free body diagram by drawing a dot. Then we start drawing the forces. The first force we will draw is the force of gravity, which is downwards. Because the object is touching a surface, there is a normal force acting on it. We have to remember that normal force is always perpendicular to the surface, so let's avoid common mistake of drawing it upwards. Due to the roughness, there is friction force between the surface and the object. We will learn about friction force in the last part of this video series. For now, we need to know that friction force always opposes the motion. Due to gravity, the object in the figure tries to slide down the incline, and friction force opposes it, so its direction will be up the incline. Both normal force and friction force are forces applied on an object by a surface. One of the main differences is that normal force is perpendicular and friction force is parallel to the surface. As a summary, in this video we learned definition of a force, how to classify the forces, and how to draw free body diagram. In the next video, we will start with the first law of motion, define inertia, and learn about the relation of inertia with the mass of an object. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.